Well, in this one, we're again trying to find the volume. In this case, the volume above the blue cone, but inside of the green sphere. So we're going to be setting up the triple integral over the region. Now, in spherical coordinates, we've got this volume element, rho squared sine phi. If you watched my videos, I showed you where that came from. Now, what we put here can either be a d rho, d phi, d theta, or any other combination of those three, depending on what we decide we want to use, or need to use, I guess. And so, let's see what we've got. We can find the intersection of these. That would be this line along the seam here between the cone and the sphere. Now again, there's part of the sphere missing. They explain that right up above. But the sphere would be here. They just cut it out so we could see the inside. So there is a circle around here that represents the intersection of those. We can find that intersection by taking this z value and this z value and setting them equal to each other. So if we took the negative 7x squared plus y squared and set it equal to the 100 minus x squared minus y squared, and then finish solving. If we square both sides, that gets rid of the negative, and we have 7x squared plus 7y squared, and 100 minus x squared minus y squared. If we collect all the variables over on the left, move the negative x squared over here, and that would be an 8x squared. Move the negative y squared over to the left, and that would be an 8y squared. And dividing through by 8, we'd have an x squared plus y squared equals 100 over 8, which I'm pretty sure reduces to, what does that reduce to? 25 halves. So that's a circle with a radius of 5 over square root of 2, for what that's worth. So if we take this cone and we use 25 halves for the x squared plus y squared, we get a negative square root of 7 times 25 halves, which comes out to be a negative square root of 175 over 2. If we used the x squared plus y squared equals 25 halves in this equation, we'd have a z equals the square root of 100 minus x squared plus y squared, which would be 25 halves. Now that comes out to be a positive square root of 175 over 2. Now you can tell from looking at the picture, here's z equals 0, and so the value we're talking about down here, the z value, is obviously going to be a negative. That's going to be from the center down to that red line. So we're talking about the negative square root of 175 over 2. So if we use that, right through the middle of the sphere here is the z-axis. Right across here is our xy plane. And so this angle from the positive z-axis down to this line is our rho. So we need to figure out, excuse me, that's phi, not rho, not theta either, phi. So we need to figure out what that angle is. Well, we know that this value right here from the origin out to the sphere, or where the cone intersects the sphere, is the 10. So that line is 10. And we know that this right here, this line, is a negative square root of 175 over 2. So we can find that angle. In fact, it'll be the same as this one by doing the arc cosine of, that would be a negative square root of 175 over 2 over 10. So this angle, you can see, is going to be the adjacent over the hypotenuse. So that'd be a negative square root of 175 over 2 over 10. And again, that would be a good time to whip out our calculator and do that. So when the TI-89 gives a weird looking answer like it does here, in fact it just says what we typed, that means it can't find the exact value. But we can approximate this. We want to just be sure and use plenty of decimal places. In fact, you can use the store button on your TI calculator and not round this off at all. But that comes out to be a 2.7802255. Now again, you can use the store key, STO, and store that in some variable, and then come back and type the letter whenever you need it. So then we know that the values of phi that are coming out in between the green sphere and the blue cone, meaning the ones from here around to there, are going to be going from 0 to 2.78, etc. And we know that the rho is going from the center out to the edge of the green, which is 10. So rho is going to be going from 0 to 10. And we're not given any information. Again, that's what they're telling you. That cutout is actually a solid sphere. And so our thetas are going all the way around from 0 to 2 pi. So it doesn't really matter how we set up our integral as far as what order we put those in, because they're all constants. So on our triple integral, again, we've got the rho squared sine phi element, and here we can do any order we want. So we could do a d phi, where phi goes from 0 to 2.78. We can do a d rho, where rho goes from 0 to 10. And then we can do a d theta, where theta goes from 0 to 2 pi. Now I'll go whip that out on my TI-89. And that comes out to 4053. And again, however much rounding we need to do on that.